let us look at example 3. Here we have z equals to 4 and we want to convert it into the polar form. Guys, it may look like it's a real number, but we already know that every real number is also a complex number. So guys, in order to write this in the polar form, the first thing that we can do is we can rewrite this with a real part and an imaginary part. So we can break it down as 4 plus 0i, because 4 plus 0i is still 4, but breaking it down or rewriting it as 4 plus 0i, now we will be able to identify or get the real part and the imaginary part. So the real part A is 4, that is my real part, and guys, my imaginary part B is 0, and that is my imaginary part. We can write a coordinate point 4 comma 0. That's what we usually do, the real part and the imaginary part. Once we have it, then we go ahead and try to plot this. So let us go ahead and plot this on a complex plane, real and imaginary axis. The horizontal axis is the real axis, and the vertical axis we call it as an imaginary axis. So 4 and 0 means real. This is the real value, this is the imaginary value. So it obviously means it is only on the real axis right here. Let us say this is 4 units away from the origin. So guys, it is only this point right here which represents 4 and 0, or it represents z equals to 4. And guys, if we want to write the polar form, we need few things. We need the r, we need the value for the r. How far is the complex number from the origin? That is what r stands for, the absolute value, right? Absolute value of the complex number. But what is the absolute value? What is the definition for the absolute value? It is simply how far, or what is the distance of that complex number from the origin. Guys, in this case, what is the distance from the origin? So distance from the origin is simply just 4 units. So that means r is going to be 4. And if you want to use the Pythagorean theorem to find it, you will still get the same thing, because we know r equals to square root of a square plus b square, where a and b are the real and imaginary parts of the complex number. And if I try to use that on this particular example, it's going to be 4 square plus 0 square. If you simplify this, it's square root of 16, which is just 4. But then guys, we don't have to do that all the extra work, because we already know that the absolute value is the distance from the origin, and we have a visual of this complex number. We can clearly see that it is 4 units away from the origin. That means r is automatically 4. The next thing we need is to find the angle theta. Again, we cannot really create a triangle or anything here, but we already know that the angle is measured with this as a reference side, and it actually just overlaps. It lies on that horizontal axis. So that means the angle here is just 0 degrees or 0 radians. So we don't really have to do any extra work. Just by looking at the plot, we can see that the angle is 0 degrees, and the rate and the r, the absolute value, is 4. Guys, we have both the things, both the quantities that we need to write the final form in a polar, or we can also think of that as the trig form. What is the trig form, guys? The trig form is r times cosine. I don't know why I keep on writing sine. It starts with the cosine first. So cosine theta plus I sine theta. Guys, z equals to r, which is just 4, and then there's a cosine of 0 plus I sine of 0. Okay, this would be the polar or the trig form. Guys, this is very simple, but I have seen sometimes students find this challenging. Guys, if you find this challenging, my suggestion is please go ahead and first plot it. Once you plot it, things become very easy. That's why with any of these examples where we have to convert from a standard form to a polar form, first of all, I like to plot the complex number, and then from there I'm able to figure out the value for r and the theta. Once I have both of those, I know the general form of writing the complex number in a trig form. Then I just substitute the values, and here we have the final answer. Okay, guys, I will see you next time with example 4. Till then, take care.